Alright, gang, moving on to 3.4. 3.4a, anyway. This one is also continuing our work with like equations that have an x variable and a y variable, so two variable equations. And this one is about solving for y, which, man, you don't even know right now. Well, maybe you do, from past experience in a previous math class at some point, how super important and helpful it'll be for us to know how to solve for y. And at least in 2018, my experience with students is like this is something that they struggle with too much. Like I want to make this, again, at least these days in 2018 with the students I have and have had and whatever will have in the near future, at least until I see a change, I want to make this a huge point of emphasis. Okay, solving for y is a skill that I think is lacking, and at the same time very important. So here we go. First, when graphing, it's nice to have it in the form of y equals, yada yada yada. Like we saw in the previous sections, it was always y equals x squared plus 2, y equals x plus 5, y equals negative 3x plus 8, y equals the absolute value of x minus 7, right? It was always y equals and then the rest of the equation. In other words, y was by itself. And now look, at this point in our class, Integrated Math 1, it's definitely been helpful to make a table of solutions and pairs of numbers that you could just plot as points. So it's helpful for that, right? When, like I said, when graphing. And so far we've seen that again, like as far as constructing a table of pairs. But here's a little bit of foreshadowing for you. There's going to be another more profound reason that we want y to be by itself. So I guess I'm not going to really reveal that yet. It'd be getting a little bit ahead of myself, but you might already know what I'm talking about. The bottom line is, darn it, it's really important to be able to actually, like here in number 1, if y is not by itself, we need to be able to get y by itself, first of all, before we talk about how we're going to use it, or how we have used it, or will use it, whatever. So in this example, here we go. We got the left side, and we have the right side. Remember, people, the left side and the right side are split up by the equal sign. The equal sign is what separates the left side and the right side. And I want y to be the only thing on its side, preferably the left side. But we might see how that plays out, that little detail. But here we go. I don't want this minus 8 over there on that left side. So it's y subtract 8. I want to undo the minus 8. And just like you've done for days and days and days and days, and maybe even months, going back to like a previous math class, we are going to add 8 to both sides, because that cancels out minusing 8, and that will leave y by itself. But what does the right side become? what is 2x plus 8? Well, you need to, if not already, holy crap, you need to know that 2x plus 8, those don't add together. 2x and 8 are not like terms. They don't add together. So what happens is this term, this 8, is just going to be over here on the right side now. It doesn't have to combine with the 2x. It could just be like a separate term that's just over there now. So in a way, what's 2x plus 8? It's 2x plus 8 is 2x plus 8, you know? And guess what? Now that y is by itself, we're done. We're done. If the directions, or if your intention is just to solve for y or get y by itself, of course I'm done right now once y is by itself. Let's move on. Well, how about this one? What can I do to make this 4 go away? It's crowding the y. It's on the same side as the y. So wouldn't we divide both sides by 4? And that will get y all by itself. But what happens on the right side? Well, this is huge, actually. When you divide both sides by a number, I mean like divide both sides. The entire right side needs to be divided by 4, which means both of these terms, the 3x and the positive 16, need to be divided by 4. So let's start here. What's 3x divided by 4? Well, of course, what we just doing, like the 3 divided by 4 and the x is just going to be along for the ride? Yeah, okay. So what's 3 divided by 4? Well, listen. Obviously, 3 divided by 4, that is not clean division. Yeah? I do not want you going decimal with this. Okay, I know 3 divided by 4 is 0.75. Okay? But again, I'm doing this for a reason. It's a little bit of foreshadowing. Leave this as a fraction. Make it a reduced fraction, but leave it as a fraction. Even if it's an improper fraction, leave it like that and just reduce it. So 3 divided by 4, that's definitely not clean division, so it's a fraction. Can you reduce 3 over 4? No, so it's just going to be 3/4 x. And then remember, you also have to do 16 divided by 4. Well, that's going to be 4. 16 divided by 4 is 4, which is a separate term over there. Okay? And that's how number 2 works. Divide both sides by 4. Just make sure you divide both terms on the right side by 4, leaving this especially as a fraction. Ooh, look at this. Here's our y. And man, there's a lot over here on the left side, okay? So here's how this one's going to play out. I got to get rid of this 2x. Like, I got to get rid of all this. I just want y to remain on the left side. So here's what I'm going to do first. I'm going to get rid of this entire term. See, not just the 2 needs to go, 2x needs to go. This whole term needs to get out of there, away from the left side. So how do I get rid of 2x? It's a positive 2x, right? Remember, this negative goes with the 3, the negative 3y. So here's what I'm going to do. I'm going to subtract 2x from both sides, and that'll leave negative 3y on the left side. What does the right side become? Think about this. Can negative 12 minus 2x do those combine? Are those like terms? And the answer is, of course they're not. They're not like terms. They don't mix together. So you would just leave them separate. Okay? Negative 12 minus 2x. They do not combine. You know, that minus 2x term is just over here now. But I want to get into something else real quick and kind of get into a certain habit. We have a negative 12 term and we have a negative 2x term. Does it matter what order they're in? Like, could I just reverse the order of these two terms? Of course I could. And what I'm getting at is, you should get in the habit right now, if not already, of putting the x term first. So my right side, I'm going to put the negative 2x term and then the minus 12 term. Okay, and if again, like, probably sooner rather than later, I'm probably going to get in the habit of, like, going directly from this step directly to here. Like, I'm not going to bother writing this step out. You know, I'm just going to say that negative 12 minus 2x, and I'm going to immediately call it like negative 2x minus 12, and not even write out this step. You know, like, eventually, like, I'll keep this going a little while, but here we go. But now we have to finish getting y by itself. Well, what's going to finish getting y by itself? Dividing both sides by negative 3. And again, dividing the entire right side, both of these terms, by negative 3. Okay, so what's negative 2x divided by negative 3? Once again, it's really going to be more about negative 2 divided by negative 3. The x is along for the ride. So negative, does that cleanly divide? No. So does negative 2 over negative 3 reduce at all? Well, yeah, with the negatives, you know, like I can at least say that something negative divided by something negative is going to be positive. So that's really all I can do. So it's going to be positive 2 over 3x. Remember, don't forget the x. And then we also have to do negative 12 divided by negative 3, which is positive 4. And that's my final answer for that example. All right, let's keep some examples going. If you want to start pausing the video and trying these on your own real quick, that'd be awesome. In order to get y by itself here, all we got to do is subtract 4 to both sides. That'll get y by itself. 3x minus 4, they do not mix. They are not like terms, so they are just separate terms. And it's important to have the x term first. Trust me for now if you don't already know what I'm talking about. So there we go, and that one's done. As soon as y is by itself on its side, preferably the left side, you're done. Number 2. Might want to try this on your own again as always, but looks like we're going to be dividing both sides by 6 to get y alone. Does negative 5x over 6 divide cleanly? No. Does it reduce? No. So it's negative 5/6 x. Remember, the x is there. And then also 18 divided by 6, positive 3. And that one's done. Go ahead and try this one on your own, pausing the video. The first thing you would do is get this term out of there. Okay, subtract 3x from both sides. That would leave 2y there. And the right side, those do not mix. Those are not like terms. They do not combine together. So I'm going to have a negative 3x term over here and a positive 10 separate term over there, I want to put the x term and then the regular number constant. Remember, this is the same. I already broke my promise. Well, I mean, I told you I was going to do it sooner than later. I guess it was a lot sooner than later. I know, like you could have written this as 10 minus 3x. I just wrote it like this. Something you need to get in the habit of sooner rather than later. And the final step to get y by itself is divide both sides by 2. And we got to divide both of these terms by 2. And this will be negative 3 over 2x plus 5. And that one's done. Again, keep pausing the video for each new example. Trying it on your own. All that would need to happen here is adding 7 to get y all alone. And over here, these do not combine, not even close. So they remain separate terms. You know, the plus 7 is now just over there. And the x term goes first, and that one's done. This one, the only thing that needed to happen was dividing both sides by 7. Nothing new here. A lot of these examples, there's like, you know, just nothing new in each example. Just same old stuff to get y by itself. So divide both of these terms by 7. 3x over 7, there is no clean division, and that fraction does not even reduce. But 14 divided by 7 is 2. And that one's done. Try this one on your own. Pausing the video, hopefully. But so again, the order always matters, right? Get rid of this term before dividing both sides by 3. So over here, check it out. You know, I could write this as negative 15 and then the minus 4x, but I am going to start to insist here that we put the x term first, then the regular number, negative 15. And then we divide both sides by 3 in order to undo that. Man, there's like never clean division here, huh, on this handout? Negative 15, well, there's clean division here, huh? I guess, but never with the x. There totally could be, though. Don't get the wrong idea. Or you could get a fraction that reduces. But anyway, negative 15 over 3, that's minus 5. And that one's done. And that does it for all those examples. Just a lot of the same stuff over and over again.